All right, good morning, good evening, good afternoon, and welcome. So we're talking about rate of change in slope, lesson 3.3, and of course I'm Mr. Stiger. Please make sure you guys have your books open to page 170 so you can follow along with the examples as we go through this. First and foremost, to start off, is the bell work. All right, in relation to the bell work, I did graph this already. Okay, so the red graph is going to represent your first equation. Our y-intercept is -2. Our second equation is going to be 1.6. And our final equation, the x-intercept is 14. So what that means on this is that it takes 14 hours for your pool to drain. Mathematical practice 2, reason abstractive. A couple different quantities. We're going to start doing rate of change. Okay, that's going to be a huge indicator for you guys as we move forward. It's going to be something we're doing a lot. You guys have been able to graph ordered pairs. Now we are going to find the slope of a line, which is going to be very important for you guys. Okay, so your first thing is you set up in your vocabulary, you should be rate of change, which is change in y over change in x. Please make sure you guys understand that it's going to be y over x. All right, you do not want to confuse this little piece of the puzzle. All right, so let's get started. Y over x, rated change. So it's going to be 152 minus 76. And the rate of change from here to here is 4 minus 2. If I were to put this into a calculator, all right, this is actually going to be 76, and it's divided by 2. And then if you figure that out, in my calculator, 76 divided by 2 is 38. So what does this actually mean? This rate of change means you're going 38 miles per hour. So you are driving really slow. Your turn. All right, for this one in remodeling, okay, rate of change is going to be 48 minus, whoops, not that way. It's going to be, we'll do 48 here, and it's going to go 96 minus 6 minus 3. This actually comes out to be 48 over 3, and you put that in a graphing calculator, or a calculator, excuse me. 48 divided by 3 is 16, okay? So understand what that means. It actually means that this is 16 inches squared off of that. So I know the size of these tiles. These are 4-inch tiles. 4 by 4, perfect square, 16 square inches. All right, next, this graph shows the number of passports issued. This is example number 2, which is going to start on page 161. All right, we have on your book an industry graph. On here, we're going to do the rate of change from 12 to 14, from 14 to 16. So what is the rate of change in years? So I'm just going to kind of skip through this. All right, since it's y over x, it's 2 years and change. Okay, so I can write this one out, but I'm not going to write the other one out. So 2014 minus 2012. All right, so you guys got it. It's 2. When you figure out this number, that's 2. And it would be 14.1 minus 13.1. Now this one over here is 18.7 minus 14.1. So what is the rate of change here? Well, this is 1. And, oops, I don't know why I did that. 14 minus 12 is 2. The rate of change is 1/2. The rate of change on this is going to be 4.6. And that's going to be divided by 2, which comes out to be 2.3. So, explain the meaning of the rate of change. Well, what it means is from 2012 to 2014, there was 500,000 passports. Now, you could write this however you want. You don't have to write it out 500,000. You could put 500,000. You could put 500,000. It's up to you. And then from this year, it was what? From 2014 and beyond, it was 2.3 mil a year. Okay, just understand what you're writing down. And how are the different rates of change shown on the graph? They have what? Different slopes. Sorry for the bad handwriting. Your turn, ladies and gentlemen. Take a look at this, see what you got. All right, this one here, so from 1995 to 2000, from 2000 to 2005, how many years is that? So for both of these, the rate of change is going to be, and the x function is going to be 5 years. And then what is the y over the top? You go from 9, so it's going to be 9 minus 8.1, and then it's going to be 9.9 minus 9. All right, so on my calculator, I know these rate of changes are actually going to both be 0.9 from looking at it. Do I have to put in the calculator? No, but what I do need to put in my calculator is 0.9 divided by 5 is equals 0.18. Okay, so what does that mean for me? Well, it's talking about explain the meaning of the slope. The meaning of the slope is actually constant and linear. Okay? And this definition, okay, would kind of be same down here. They are not. They are the same. Okay, or linear. It's kind of what you're doing. And then what is the slope? The slope represents how many departures in millions. So remember, if it's 0.18, if you guys go back to your elementary school days, you'd want to go. If you go to a million, it's actually going to be 6 decimal places. So it's 1, 2, 3, 4, 5, 6. If I plug in the zeros here, how many departures of flights left a year? 180,000, okay? So every year, it looks like they have 180,000 departures in from the United States. Now, on this one, make sure I got it right, okay? Next. Example 3 does start on page 162. All right, and on 162, you need to be able to take a rate of change from a table and explain whether or not it's linear. Linear function has the same constant speed, okay? It's going to be the same constant rise over run, which we're going to learn about in a second. So what I mean by that is the change from here to here is what? This is plus 1, this is plus 1. I'm going to actually cheat, and I'm going to have the book show you how to do it. So what they have is the change in y. 12 minus 6 is 6 over 2 minus 1, which is 6. Okay? So it'd be 6 over 1. That change is here. That change goes to here into here. Okay? So on your notes, I believe I put a table. Make sure you guys understand this portion of it. So if you have to pause the video, please do. But the rate of change is constant. Thus, the function is linear. All right, now we need to determine whether this function is linear. So, what is the constant rate of change? So if we do the same thing we did before, which is 5 minus 1, and that's going to be over negative 2 minus 10. Okay, that's your first rate of change. You can spell this out, and it's going to be 4 over, that's a positive, that's going to be 8. Okay? And that is what? Negative 1/2. All right, so if you do the next one, what I don't like about this is it's kind of taking me a while, and you got to do the math on it, and there's a lot of craziness. Think about this, ladies and gentlemen. If you're the rate of change from here to here to here, it should be a constant rate. Okay, so from here to here, from 10 minus 2, if you guys were to be on a number line going left to right, this is going to be 8. Okay, it's actually, is it positive or negative? It's actually positive. So if to go from negative 10 to negative 2, you're going to add 8. Okay, from negative 2 to 6, you're going to do what? Add 8. From 6 to 14, you're going to do what? Add 8. Sweet, that's awesome. Now, from here to here, now let's do this change. From 5 to 1, you're doing what? How would you go from 5 to a 1? You would subtract 4. All right, from 1 to a negative 5, what is the rate of change from 1 to negative 5? Well, you'd actually subtract 5. And then to go from a negative 4 to a 6, you'd actually do what? Subtract 6. So here's the question. Here's a constant rate. Is this a constant rate? No, it is not. You can see it should be negative 4, negative 4, negative 4. So ladies and gentlemen, this is not a linear function. No. Now the book kind of will go into the same thing about this detail, but what I want to make sure you guys understand is it's easier if you just look at each column individually and see if they both change at a constant rate. If they do not, it is not linear. Your turn. All right, check this one out. Let's see. -3, -2, -1. That is 1. All right, to go from here to here, you would add 1. You would add 1. Whoops, did that one wrong. Add 1. Add 1. From -1, to 1, you actually have to do what? You would add 2. Right there. Do I have to do anything else? Nope. This, ladies and gentlemen, is not linear. Because don't forget, -3, -2, -1, there should be in here a 0, and it's not. All right, so rate of change from here, 12 to 9 is -3, -3, -3, -3. Hopefully you guys see that. If I subtract 3 each time, it's the same thing. All right, this one, if I go from -4 to 1, I'm actually doing what? I'm adding 5. Add 5, yep, 5 plus 1 is 6. 5 plus 6 is 11. 5 plus 11 is 16. So ladies and gentlemen, this is a yes. That is a linear function. All right, big key term, ladies and gentlemen, the slope. We will use this formula extensively throughout the year. Please make sure you memorize this formula. Remember it. If you haven't learned it last year, most of you I think did, y2 minus y1 all over x2 minus x1. So usually your x and y, does it matter where the coordinates are at? I've thought about this a lot and I had questions about it last year. No, you pick your farthest point that you can visually see or think about. That would be your 2 points, okay, your x2 and y2. And then you would want to subtract your closest to the origin, right? The point closest to the origin should be your 1 point. Find the slope of a line that passes through the following, okay? We're going to set the formula up. Remember, it is y2 minus y1 all over x2 minus x1. That is your slope. Please make sure you know that. All right, so now we just plug in the values. So for our y coordinates, we're going to go with the farthest point to the right as being our 2 coordinate. So it's going to be 5 over 5 minus minus. And our y coordinate for the second point is 2, and the x coordinate is -3. We can rewrite this. 5 minus 2 is 3. And then remember, this is a negative, and that's going to be negative, and negative is a positive, so it's going to be 5 plus 3. 3/8. All right, find the slope of a line that passes through these points. y2. So here's your y2 function right here. This is your y1, x2, x1. All right, so if we got our y2 coordinate, it's -8. And then our x2 is going to be -2. Our y1 is going to be -4. And then our x1 is -3. Okay, now if you write it up just like you see it, ladies and gentlemen, now you just switch the signs as you go along. So remember, negative and a negative is positive, so I'll write it out one more time. And then it's going to be -2 plus 3. And the final solution is to combine is to actually do your math. So -8 plus 4 is -4. 3 plus -2 is 1. So what is your rate? Your rate is actually going to be -4. Now, you can leave 4 over 1 so that you know the rate of change is going to be, the y value is going to be rise over run, okay, rise up. So it's actually going to be down -4 and over +1, down -4 over +1. I had to think about that for a second. Find the slope of a line that passes through this. So that's another key term, okay? You guys remember the rise over run factor, right? So this is the rise part, and this is run, because you run horizontally, but you rise up and down. Please make sure you know that. So the slope, y2 and x2, so sweet, it's easy to begin with. 4 minus 4 okay? And then your second coordinate point is 4, and the other coordinate point here is a -3. So I get 0 over 7. So what does that mean? Does that mean 0? Does that mean undefined? Well, let me think about it for a second. If I go on a number line and I go 4 over 4 up, there's a line. And I go -3 over 4 up, there's a line. What kind of horizontal line is that? Or what kind of line is it? It's horizontal. So the slope of this line equals 0. All right, because basically it's flat. It's 0. Your turn. Do the rise over run. All right, slope. Make sure you guys got it. So 8 minus 6 over 4 minus 3, okay, which is going to be 2 over 1 or 2. Make sure if you understand the rise over run part. Okay, so on this one here, my function's -2, 0, and then it's going to be -2 and -4. All right, and make sure I do the proper annotation. So this changes out. That's actually going to be 0 over 4. So that's going to be another horizontal line. And by looking at it, I go 0, -2, and then -4, -2, and I can imagine it is a horizontal line. So the slope is 0. Okay. On this one, your y coordinate would be 10 minus 2. And then it'd be -2 minus -4, just like that. Whoops, put that in the wrong spot. So it'd be minus -4. All right, so the rise is 8. And then this changes to a positive, so it'd be -2 plus 4, which is 2. So my slope would be 4. Hopefully I've done all these correctly, ladies and gentlemen. If I haven't, please come tell me and say, Mr. Stiger, your math is completely wrong. It happens. All right, find the slope of a line that passes through -2, -4, and -2, 3. All right, so let's do the rise over run. So, or y2 minus y1. So y2, in this instance, we'll go 3 over -2. There's your first 2 points, okay? And then your second point is going to be a -4 and a -2. All right, and this equals what? That's positive, so it's 7 over 0. Now, what happens when you have a 0 in the denominator of any type of fraction? Ladies and gentlemen, this becomes not a real number, or it's what's called an undefined slope, which if you guys look in your notes, you'll see we're going to talk about in a second. Undefined slope. What kind of line is this? Okay, this is actually going to be, if I go over -2, down -4, I go over -2, up 3, what kind of line is it? It is a vertical line. So if it's a vertical line, it is an undefined slope, because basically it's straight up and down and you can't define it either way. All right, so undefined slope equals vertical line. All right, you guys try these guided practices and see if you can get them through a point. Now, I could do the math on this, ladies and gentlemen, or I could actually, I'm going to try to plot these out in my head to go a little faster. 6 over 7 up, it's going to be right here. 6 over 3 up, it's going to be right about here. What kind of line is this? It's vertical, undefined. All right, my next one here, if I go, imagine -3, 2 up, -3, -1, same thing, okay? Vertical line. So it is undefined, both of them. Here is your examples, okay? Remember, we're always looking at slope here from going from left to right. Always left to right. So when you're looking left to right, okay, if it's going up, it's positive. If it's going down, it's negative. Remember that. Horizontal line, slope of 0. Vertical line, it is not a function and it has an undefined slope. This is very important for you guys to understand as we're talking about negative and positive slopes as we go forward, is reading a graph from left to right and understanding what you see as it's going. Find the coordinates given the slope. So now we're going to be going more into the harder math. So if you remember, it was y2 minus y1 over x2 minus x1, and that equals what? Your m, which was your slope. So now what we're going to do is we're actually going to solve for a hidden variable and use our wonderful algebraic skills that we have learned so far this year. So our first coordinate, okay, we're going to just do, it doesn't matter which way you go, we're going to go, the first point is going to be, I'm going to make it 6 over 3. Okay, actually I wrote that wrong, thank you very much. The y coordinate is 3, that is 6. All right, and then we have our, this is going to be minus, minus, and our coordinate here. Well, as I think about it, do I want to have this as a negative? No, I don't. So let me rephrase this. So see, this is kind of stuff that you guys can do as you're getting ready to write it out. So if you guys wrote it down, I apologize. But for me, sometimes it's a thinking process. I want to make sure I get it right. So let's make this one the 2 over r, so that way this variable isn't negative, okay? All right, and then the other point, the y coordinate is 3, and the x coordinate is 6, and your slope is 1/2. So now what you want to do is solve for this. So let's simplify it first, okay? Simplification means do the math on the top. So 2 minus 3 is going to be -1 over r minus 6 equals 1/2. Now here, ladies and gentlemen, is where things get a little tricky. All right, there are two ways that you could possibly solve this. All right, the first would be, remember, we usually don't want to mess with the r, the variable that we got to find for, but it's in the denominator. So we're going to have to shoot it over to this side of the equation. So if this is division, if this is a fraction, how would you move what's in the denominator? If you guys remember, multiply both sides by r minus 6 over 1. Okay? R minus 6 over 1. If you do that, remember, r minus 6 divided by r minus 6 will equal what? It will equal a 1. Okay? Now, the question is just leave it like that. Okay? So what's left behind? What's left behind is a -1. And that's going to equal r minus 6 over 2. Just like that. Now, ladies and gentlemen, what do you think the next step would be? Well, the next step for us in this case would be to multiply this back over to 2. So I know this seems complicated. You're like, what in the world? But, or remember what this actually means is it means 1/2, and then it's r minus 6. Okay? So if I write it like that, you guys hopefully can understand and see that how do you get rid of this fraction? All right, this and this are the same thing. You'd multiply it by 2. If I multiply this by 2, now I'm left with -2 equals r minus 6. Lastly, you can do what? Add 6 to both sides. R equals 4. Whew. So that other coordinate point that we're looking for here is what? 4. That was a lot of work. Let me put the math back up. If I went too fast, rewind the video, back it up, look at it again, okay? Please understand how I got here, all right? You're looking for, here's your original equation, here's your substituting into the points, okay? Then you simplify. 2 minus 3 is -1, r over 6, and then it's 1/2. And then understand, ladies and gentlemen, from there, you've got to get this r out of the denominator. The only way to do it is to multiply it by the reciprocal, or multiply by what's in the denominator, r minus 6, r minus 6. And then you would rewrite the equation in the green, okay? So it'd be -1 equals, then you have a fraction, multiply by 2, and so on and so forth. Hopefully you guys understand that. In case you don't, here are 2 more to please try on your own first. All right, last piece of the puzzle. I've already written this out because this is kind of long. So, same thing. All right, y2 minus y1 over x2 minus x1. And when you set it up, ladies and gentlemen, you can kind of see how I did the setup here, okay? And then I got to this point. Now, I did the same thing over here. I wrote the equation out initially, and then I got to this point. And then from there, all right, I multiplied the denominators over, so I end up with an equation. Now, I did do this two different ways, okay? The first ones I distributed. So on this one on the right-hand side, I distributed. So you can see I took the negative 8 times 5, negative 8 times r, and I can get negative 2 equals negative 40 plus r, 8r. All right, then your next step would be to add 40 to both sides. So if you add 40 to both sides, okay, you cancel out and you get 38. 38 equals 8r. You divide by 8, and you end up with 4 3/4, okay? This would be kind of doing the same thing, all right? You set it up initially, but instead of distributing, I actually took this equation and I factored out the negative 8. All right, now when I did that, I got negative 2 over negative 8, which would be 1/4. Then I subtracted 5 from it, but then I had a negative r. So this, in this case, this one here, I would try not to do it. Okay, now if you want to see what that looks like, I would prefer you guys do this method. If you want to see what it looks like, that's what it looks like, but the purple is kind of out. And then on this one's kind of the same thing, okay? You set it up, you do the distribution, you distribute, you get negative 10 minus 5r minus 10. Add 10 to both sides, you actually get 0, okay? And when you get 0, anything divided by 0 is going to be what? R. All right, on this one, I did the same style of math. If you prefer this method, use this one, but most of you in my class will use the distribution method first, and then you solve for the variable, okay? Ladies and gentlemen, the end was very difficult, but leading up to it should have been easy for you. The homework should be in the comments below. If you guys have any questions, please see me in class. Other than that, everybody have a great day, and I will see you soon.